My name's Billy Burton. I'm a liquid measurement coordinator at Coastal Flow Measurement. We're here today going to be doing some demos here in our Coastal Flow office. We're staged right now in the warehouse where we do a lot of our flow testing and a lot of our maintenance work. I'm hoping to help you out today and give you a little better understanding of the operation and the functionality of preamps and pickoff coils. These are some common components we see here, and you'll see some versatile different options here on the table. I've got some here laid out, as well as some different mag coils, and I think it's important to go over some of these and go over some of the terminology first. We have some different industry terms out there that can be a little bit confusing or can also be interchanged a little bit. So you'll hear some of the common terminology as pickoff coils, pickups, pickoffs, mag coils, preamps, amplifiers, preamps. Those are all referencing two really common components. And today I'm hoping to show you how to test these, how to identify some errors, and how to function test them overall. So probably the most important thing to go over is the tools you'll need. We've got some basic parts, some flathead screwdrivers here, a voltmeter. Today we're simulating with external power supply to actually power the device, as well as a frequency generator here that we're going to simulate signal in. So first off, what we want to do is turn our power on here to the device. Typically these units run somewhere between 6 to 24 volts DC. So first thing we're going to check here is our DC voltage coming in. A lot of times these will be identified by labels on the side of the device. So I'm going to select DC voltage on my voltmeter. You can see here on the input voltage I'm reading just over 24 volts. So we know that we're supplying the correct amount of power. The very first component you'll see on here is the mag coils, like I mentioned. So give you a brief functionality of these, the way they actually work, obviously in the term mag or magnet coil, what these do is they actually screw down typically into your turbine meter, into the housing. These are some threaded models, so I say screw down, but you do have models that drop into place. These are all common components that you'll see with different manufacturers, so they vary a little bit, but basically the same functionality between them all. So what this does is it actually sits down in the housing, and you'll have your metal rotor blades inside actually in place in the fluid path. And what this magnet does is it sees each time one of these blades turns by, it outputs a signal. And we see that signal as a sine wave input to our preamplifier. What our preamplifier does is just that. It amplifies that signal, the sine wave input into the preamp. And what it does is it applies a little voltage to it and drives out a square wave pulse and allows that signal to be driven over very long distances. This is typically really important when it comes to flow computer setups that may input these pulses great distances away, and they're really common with portable proving setups as well that require a stronger signal driven into their equipment. So like I said, what we'll check is the mag coil input. We're looking for right now on our frequency generator, I have us dialed into 1,000 hertz. And I will put my leads here, and what I'll do is I'll adjust my input to read that frequency in, and I can see 1,000 hertz here coming in to the preamp. So what you'll hear a lot of times is the references to the input or the output side of a preamp. Input typically or I shouldn't say typically, always really refers to the mag coil input. So we're taking pulses from the meter into the preamp, so hence the input side, and then we are amplifying that signal and driving it out. So what I want to verify is my 1,000 hertz input. It is there. Now I want to check and see that I have 1,000 hertz being output, and I can identify that it is. I do have 1,000 hertz in and 1,000 hertz out. So I know that this preamplifier is working properly. Now in scenarios where maybe I suspect that the preamp or the pickoff might be malfunctioning, how would I go about testing that or verifying it? So the first step really is to start at the beginning of the chain, verifying our signal from our mag coil. So a lot of times it's good to test it. You can test it at the preamp and verify whether I have 1,000 hertz coming in, like I mentioned previously. Sometimes it may be necessary to unterminate your wires. So what I would do is remove these wires just in case there's some kind of short going on internally or something not making connection within the preamp. Could be causing a ground out issue. And I want to verify that I do have the correct frequency coming out of my magnetic coil. If I verify there I do have my 1,000 hertz or whatever frequency I'm expecting to see, then I can move on through the process. Now if I decide to put these back on here, we can go to the next step. Sometimes these little wires are difficult to deal with. All right. So now the next thing I want to do, as I mentioned earlier, it is a powered device. So the next step you want to go to is to verify that the device is receiving the right amount of power to operate. So like I said, some of them will operate anywhere from 6, 12, 24 volts, in some cases higher, but they're usually in that range. So the first thing I want to do is verify my supply power. If I look at it here, it is good. I know I'm getting the correct amount of power, so that's not the issue. One thing that's worth mentioning is how the preamp actually generates that stronger frequency, that square wave pulses. It applies the DC voltage on the output side of the preamplifier. So the next thing I want to do is verify the voltage on that output. Now I mentioned that it drives the frequency out, but it should be the same as your mag coil. So I would be expecting to see 1,000 hertz. Now it can passively push through here, but it lacks the current to drive that signal. So I may see, in some cases, I may see the correct frequency, but if I don't verify the actual DC voltage that should be there, I may not get a successful proving. I may see an error on my flow computer or whatever software I'm using. So most commonly, this is the issue that we see when they malfunction. A lot of times it's the lack of sufficient voltage on that signal. If I check there, of course, this one's working properly. We have the right voltage. So these are just a few common things you can look for. There's not very many components involved with turbine meters typically, so that makes them a lot easier in most cases to troubleshoot than some of the more advanced meters. The voltage, as I mentioned, coming in, supplying power to your preamp, the mag coil that's actually inputting pulses into the preamp itself, and then the transference of that voltage onto that signal going out to the flow computer. So I want to thank everyone for watching and being involved here. Hopefully you learned something and it was helpful. That is the overall functionality test of preamplifiers and pickoff coils working together in a turbine meter output setting.